So we are studying the neutral points. So neutral point is a point at which the electric field due to individual charges is zero. So neutral point is a point at which electric field of individual charges cancel each other. We have seen this is a neutral point. The electric field is zero at this point O. This is neutral point. Neutral means no electric field. Here a charge Q is placed, positive charge, and here a positive charge of 4Q. This charge is this charge is 4 times of this charge, and we want to find the neutral point of this system. Neutral point, neutral means electric field zero at that point. So in this case, the neutral point will lie near to the smaller charge. Suppose the distance is A and this distance is B, where V is greater than A, so N is the neutral point. So neutral point means when you will calculate electric field due to this charge, when you will calculate electric field, this is positive charge, so the direction of electric field will be in this direction. Suppose this is charge at 1, this is charge at 2, direction of E1 is there in this direction, and E2 is in this direction, because this is positive charge, and at this point due to this positive charge, the direction is away from this point, so this is E2, and at point N E1 equal to E2. And if you will write the value of E1, what is the formula? KQ divided by distance square, K and Q, because we are finding the electric field due to this charge at this point. This is Q divided by distance square, means A square. And if you will find E2 means due to the charge this, so you will take K into 4Q divided by B square, But here you can see B is greater than A. So means if B is greater than A, it implies that B square is greater than A square, and you are dividing E2 with B square, which is greater than A square. It means that E1 is greater than E2. E1 is greater than E2. So if E1 is greater than E2, so for the electric field to be cancelled out, this neutral point will lie here. So you can say at neutral point, I am just telling this for your revision. At neutral point N, E1 is equal to E2. This is the neutral point. This is A1. This is A2. Both are equal and opposite in direction. So at the at point 10 there is no electric field. So you can say neutral point of a system two-point charges lies near the smaller charge. Smaller charge. This charge, uh, this charge is greater, so the neutral point will lie near the smaller charge. Getting my points? Electric field at the center of symmetrical system is zero. Electric field at the center of symmetrical system. Symmetrical means, we'll see, number one, if this type of system is there, system means there will be charges and those charges are separated by some distance. And symmetrical system is this is symmetrical system means both charges are equal. So in this case, the neutral point will lie at the center. Neutral point will lie at the center of line joining the two charges. Center means if this distance is A, then this distance will also be A. If this distance is A, then this distance will also A. What is the meaning of symmetry? I am just giving one example. I have taken a circle, and this is the center of circle. Now what I am doing, I am taking a knife and cut this circle. And after cutting, we will have this part 1, and another part 2. This part 1 and part 2 will be same, means this circle is symmetrical about this line. Diametrical, this is the diametrical line, you can say. This is the meaning of symmetry. Take a knife and cut this from here. You will get same. Cut this. Okay. So symmetry means this. So if two charges of equal magnitude are placed, these are point charges. One and two is symmetry. About diameter. This is circle. This is the equilateral triangle. And if here is a +2 charge is placed at the vertex, at this vertex a +2 charge, and at this vertex a +2 charge. So this is the symmetrical system. This is a symmetrical system. Take a knife and cut this from here. You will get same. Take a knife and cut from here. You will get same. So at the center of this, the electric field will be 0 due to these three charges. At the center, there will be a neutral point. Neutral point means the electric field will be 0. At n, electric field net equal to 0. Net electric field means electric field due to this, due to this equal to 0. At the center of symmetrical system, the net electric field due to all the charges is 0. And this n point is the centroid of this equilateral triangle. Centroid. Of triangle. Equilateral triangle. Centroid. If this is a centroid, then the distance between this vertex and this point is same. This distance will be same. This is A, this is A, this is A. Not B, this is A. This is the speciality of centroid. If this is a square, and if here minus q charge, minus q charge, minus q charge, minus q charge is placed at the vertex, then at the center of the square, the net electric field due to all the charges, this is will be the neutral point, and is neutral point. And the neutral point means E net, net electric field due to all charges is equal to 0. This system is also symmetric. Take a knife and cut this system from here. You will get two similar parts. Take a knife and cut this system from here. This is a square. And we know the square have all sides equal. And distance, this distance, this distance, this distance, this distance, this distance will also be equal. So here we can say at the center of symmetrical system, the electric field is 0. Equal to 0 at n. N is this point and center point of the square. Four charges are placed this is a pentagon, regular pentagon you can say. Regular pentagon means all sides are equal. And this is the symmetrical system. Take a knife and cut it from here. You will get two similar parts. And if you will find the electric field here at the center of this system, you will get 0. This is the neutral point, and this point is the neutral point. N is the neutral point. N is the neutral point is a point where the electric field is 0. This is E suffix net, net electric field is equal to 0. So here we can also say that at the center of symmetrical system, the electric field is 0 due to all the charges. These are positive charges, and if you will place here the negative charges, all the negative charges, then also the electric field at this point will be 0. Now, if you are taking a circle, means a disc or a ring having uniformly distributed positive charge. This charge can also be negative, and at the center here there is a neutral point. Means E net at the center is equal to 0. Electric field at this point equal to 0. Similarly, if you can take the negative charge, similarly you can take the negative charge here, then also the electric field will be 0 at the center. So I am taking negative charge. At the center there is a neutral point, and we can say electric field at the center equal to, this is uniformly distributed charge. This is also the symmetrical system. Symmetrical systems. So please note it down. Please note it down.
So can you scroll? So done.
Is it okay now?
Yes, sir.
You can write now. Now we have more area as compared to before. Completed.
Yes, sir.
Now please remember this point. Please remember this point. Electric field at the center of symmetrical system is zero. Symmetrical system is zero. This is a regular pentagon. Regular pentagon, and here a plus q charge is placed. Here a plus q charge is placed. Here a plus q charge is placed. Here also a plus q charge is placed. But here there is no charge. This is the regular pentagon. of side regular pentagon of side Okay, so this is a regular pentagon. Four positive charges are placed at four corners, and at one corner there is no charge, and we have to find the electric field at the center. We have to find the electric field at the center. Okay, and this pentagon has a side A. This side is A, this is A, this is A, this is A, this is regular pentagon, and this is the triangle, and this is the equilateral triangle, means this side is again A, this side is again A, this is again A, this is again A, this is again A. Okay, and this is point O where we have to find the electric field. Suppose if this pentagon is like this, we know that at the center of symmetrical system, the electric field is zero. This is the same pentagon, but I have increased the size. This is the point where we have to find the electric field. And suppose I have placed a positive charge here. I have placed a positive charge here, and I am giving the name of the site. This plus Q charge is placed at A. This is at B. This is at C. This is at D. This is at E. Okay, Bhumi, are you getting this?
Yes, sir.
Fine. So I have placed this positive charge by myself, and now you can see this is a symmetrical system. Now this is the symmetrical system this time. If we have placed a charge plus Q, I am writing here, if plus Q charge is placed at point E, the given system means this pentagon having charge. The given system will become symmetrical system and we know that this is the center point, and we know that at the center, O is the center, at the center of the symmetrical system the electric field is zero. At the center of pentagon, the electric field due to all the charges will be zero. So now if I want to find the electric field due to the charge at A at point O, so it means that you can say electric field at point A, B, C, electric field T, D and E. So electric field due to charge at A, the vector sum of electric field due to charge at A, B, C, D, E is equal to 0. Okay. Actually, the answer here, we have to change the question. Find the electric field at the center of pentagon. सही तो है. Okay, it is fine. We have to find the electric field at the center of pentagon. And earlier there was, we have to find the electric field at the center of pentagon due to these 4 charges at this point, at A, at B, at C, at D. A, B, C, D. And at E there is no charge. We have just placed the charge for solving the question. So what I am doing, and this is the net electric field. Net electric field at point O is equal to this, and you will, if you will calculate this, you can write this. EA plus AB plus EC plus ED. This will become minus of, this is going here, so this will become electric field at A. Okay, and we have to find this. We have to find this. I am taking the modulus. We have to find the electric field due to the charges at A, at B, at C, at D. We have to find the electric field due to the charges at A, at B, at C, at D, and we have to find this. And this is equal to electric field due to the charge at point E. So simply calculate the electric field at point, magnitude of electric field at point E, and at E we have placed the charge plus Q, and due to this plus Q charge, this distance is A, and we have to find the electric field at this point due to this charge. Bhumi, please tell me what is the value of electric field due to this positive charge at this point, and this point is at a distance A from this charge. What is the value of electric field? Electric field due to E. We have the formula of electric field, na? KQ by R square. You can write in the chat if you are not comfortable. Electric field at E will become K, and this Q charge divided by distance A square. Simple. So this value means net electric field due to EA plus EB plus EC plus AD will become EE. Means only the, we have only the magnitude and this EE.
Sir?
Yeah.
Sir, can you scroll a bit up? I'm not writing, I just want to see one thing.
Very good.
Oh, okay, sir. I just wanted to see the diagram for reference.
Yeah. So I have just calculated the electric field due to this charge at this point. Simply, electric field due to charge at E is equal to kq by A square. Simple. Kq by distance square. So EE, if I take the mod of this will become EE, and this will become kq divided by A square. Now put the value. If minus sign, then there is no problem. In the modulus, the value outside the when you will take modulus, the value will become positive, and this will become kq by r A square. So the required answer is the net electric field. So we can say E net due to charges plus Q charge at A, B, C and D is kq by A square. E net equal to NET net. This question is a little bit typical. You can say you have to think in this question. And I am not doing this question first time. I have done this question many times. So that is why I am doing this question very easily. Okay. So please note it down. With the practice, you can also solve this question very easily.
Yes, sir. Sir, I wrote this already.
This one also.
I drew the diagram. I have to write.
Please write. And if you will do the practice, then you can also solve this question. As on the fifth corner, there was no charge earlier, but for solving the question, I have placed a positive charge here so that the system will become the symmetric. I have not, I can also place negative charge at point E, but I have not placed the negative charge because the system that then will become not symmetric. We have to make the system symmetric, as we know that at the center of symmetrical system, the center of symmetrical system, the net electric field is 0. Okay, you have written completely, Bhumi? You have written?
No, sir, this afternoon.
This is, I think, a good question. Okay. You have written this also?
Yes, sir.
Okay, Bhumi, now you can leave the meeting, and if you have any doubt, you can ask me, and please revise your notes. Okay. Okay, thank you.
Yes, sir.